Hello everyone, welcome back to lesson number 10 for Calc AB. This lesson we're talking all about the chain rule, and for this particular video we're going to talk about the chain rule with trigonometric functions. So the first thing I want to talk about before we get to the problem sets here is the fact that when you're taking a derivative of a trig function and you have a theta, so let's say we have y equals a trig function and we have theta, then your derivative is going to be equal to the derivative of your trig function, so whatever the trig function is. So you look at that first. Then you're going to leave theta alone, and then you're going to multiply by the derivative of whatever theta is. So with that being said, if you guys look at example number 10, it says f of x is equal to sine of 2x. Well, our derivative for our function is simply going to be equal to, well, right now we don't care about the 2x. All we really care about is the fact that sine, the derivative of sine, is cosine. So we're going to write cosine, and then we're going to leave the 2x alone. And then our I is going to be focusing now on the derivative of 2x. So now we care about the derivative of theta. Well, the derivative of 2x is simply just going to be equal to 2. So then our first derivative of this function of sine of 2x is just going to be 2 cosine of 2x. So pretty straightforward answer for that problem. For the next one, number 11, I want to tell you guys really quickly, and I'm going to just do like a little side note here for this. So I want to just actually say, before we get to tangent squared x, if you guys look at sine squared x, very commonly missed mistake. Students always think the derivative of sine squared x is cosine squared x. So I encourage you guys, for any time you guys see a trig function that's raised to a power, to just simply rewrite it like this first. So it's the quantity of sine x all raised to the second power. And so when I ask you guys to find the derivative of this, you're going to use the chain rule. And so you're going to pull down the 2, and then you're going to leave everything inside the parentheses alone. So you're going to leave sine of x alone to the first power, right? To the first power. And then you're going to multiply by the derivative of sine. And so the derivative of sine is cosine of x. So the derivative of sine squared x is actually equal to cosine squared x times cosine. And just so you guys know and you're aware of this, that the 2 sine x cosine x is also equal to sine of 2x. So this is an identity that you probably want to eventually, make sure you are good with as we move throughout this course. And there's a couple other double identities that we're going to get to a little bit later on. But right now, this goal of this video should just be focused on finding derivatives of trig functions using the chain rule. So we're going to kind of put that on the back burner for right now and just actually start going back to this. So now that you guys know what I say right here for this problem, then we're going to rewrite this as tangent of x quantity squared. And then I want to find the derivative of this, right? The derivative of this. So it's just the same thing. We're going to move the 2 down. We're going to leave everything inside the parentheses alone to the 1 less power, which is just to the 1. And then we're just going to focus, guys. We're going to focus right here on this derivative. The derivative of tangent is simply going to be secant squared. And so this is our answer. Our derivative of tangent squared x is going to be 2 tangent x times secant squared x. So let's go a little bit further with our chain rule derivatives and now look at example number 12. And for 12, we're going to look at it again. We're going to rewrite this as cosine of 2x all raised to the second power. Okay, so let's find this derivative. So we're going to go ahead and do f prime of x, and just like in the previous example, we're going to move the 2 down. We're going to leave everything inside of the parentheses alone. Leave it alone. Don't touch it. It's sacred right now. We don't want to do anything with it. Cosine of 2x. We're good. To the 1 less power. And now, ladies and gentlemen, our eyes focus on what's inside the bracket, the whole bracket. Now, I want you guys to understand that what's inside here is really similar to example number 10. So we're finding the derivative of a trig function and a respectful theta. So when I'm finding this derivative, I want to take the derivative of cosine. Remember, cosine begins with C. C stands for change of sign. So we're going to get negative sine, and then we're going to leave now theta alone. Theta is going to be left alone. And now we're going to go further with this and say, well, we got to take into account now the derivative of our theta. So then we're going to multiply this by 2. Okay, so that means that we had a function inside of a function inside of a function, right? So we had 2x, which is our theta, inside of the cosine of x, which is all inside of x squared. So sometimes you're going to do it multiple times, but this is probably the most difficult thing that you're going to see us do. So let's continue on with question number 13. And like I said, guys, after a while, you're going to just get used to this. They're the same questions, just with different exponents and different trig functions. So in this one, we're going to have sine of 3x under the square root, which is just, again, sine of 3x raised to the 1/2 power. So when I want to find the derivative of this function, I'm going to go ahead and bring the 1/2 down. And yet again, I'm going to leave everything inside of the parentheses alone to 1 less power. And then I'm going to multiply by the derivative of what's inside here. I'm going to multiply by this derivative, which is going to be sine. And again, I'm going to leave, sorry, the derivative of sine is cosine. And then I'm going to leave my theta alone. And then I'm going to multiply by what's inside of here. And so I'm going to get 3. And so this one, when we simplify it, the cosine of 3x times 3 is going to be in the numerator. And then the 2 square root of sine of 3x in the denominator. And you can leave this as to the 1/2 power if you want to. All right. For question number 14, this one, you could literally go and do the sine x squared and do the same method we just did right here, or realize that the property sine squared x plus cosine squared x is actually equal to 1. So rewriting is also really awesome to do. As a matter of fact, I think that if I gave you guys 2 sine x cosine x, I think finding the derivative of sine of 2x is much easier than using the product rule to solve for this problem right here. But again, either way is going to work. So this derivative is just going to simply be 0, right? This is going to be 0. So pretty awesome thing with that. For 15, this is going to be kind of in the same ballpark what we're going on here. So we have this as 6, and then we have the cosine of x squared all raised to the 3rd power. Okay, so the 3 is just on the cosine of x squared. And so when I want to find this derivative, then I'm going to move the 3 down, and I'm going to get 18. All right, 6 times 3 is 18. And then I'm going to do cosine of x squared. So again, I'm leaving everything inside the parentheses alone to the 1 less power. And then, like many times before, our focus now goes inside the parentheses. So I'm going to multiply this by, again, cosine is negative sign, changing that sign. We're leaving x squared alone. The more we do this, the better we get at it. And now our focus goes to this parentheses, and then we're going to multiply by 2x. And this is all that we do. This is all that we do. Fantastic question that we're good here. So if we were to simplify this, which we really don't need to do so, it would just be negative 36x times sine of x squared times cosine squared of x squared. Right? Some crazy stuff there. Some crazy stuff there with this. So let's look at the next couple of examples where we're now dealing with non-sine and cosine, even a couple of them actually are. And so, again, just more practice, more practice, more practice. Now this one, ladies and gentlemen, this one's a little bit trickier for students just because the theta is the square root of 5x. So this is all underneath a radical. So for question 16, we're going to take the derivative of this function. We're going to leave what's inside the parentheses, or our theta, alone, and so we're going to take the derivative of tangent. Well, the derivative of tangent is going to be secant squared, and we're going to leave what's inside the parentheses alone. Now again, because both of these are underneath the square root, really what this is my little side note, this is really going to be 5x to the 1/2 power. So when I take this derivative, I'm actually going to do 1/2 5x to the negative 1/2 power, right? I'm going to 1/2 it, leave it alone to the 1/2 power, and then multiply by 5. Students always think that this derivative is just the square root of 5, but it's not, because it is a power over both the 5 and the x. So we have to do this problem right here. And so this problem then simplifies down to 5 secant squared of the square root of 5x all over 2 times 5x to the 1/2 power. Okay, so it looks a little bit weird, but it is what it is with that problem. So I'm hoping that one's going to make sense. So 17, we look at this, and again, ladies and gentlemen, this is really similar, if not almost ridiculously similar to question number 15, where we have a constant, we have a trig function, we have a power, and we have a function inside of it. So we're going to do the exact same thing we did with number 15. We're going to take the rewriting. So we're going to go leave the 3 outside, right, because the square is just only on the tangent. And so when we take this derivative, so h prime of x is going to be equal to, we're going to move the 2 down. 2 times 3 is 6. Tangent of 5x to the 1 left power, so 1. And then just like before, guys, we look at the derivative of what's inside of our bracket. So the derivative of tangent is going to be secant squared. We do not care right now about the 5x. We just write down whatever theta is. And then finally, we focus on the theta, and we get the answer is 5. So this is going to be 30 tangent of 5x times secant squared of 5x. Okay? So the next question, number 18. This one, we've actually done really easy questions with this one because right here it's just cosine of 2x minus sine of 3x. So we find the derivative of this one separately and this one separately, and we put them together. So h prime of x is going to be equal to, well, the derivative of cosine is going to be negative sine. Again, we leave the 2x alone, and then we're going to multiply by the derivative of what our theta is, so 2. And then we're going to go ahead and do minus. We're going to look at the derivative of this. Well, the derivative of sine is positive cosine. We're going to leave the 3x alone, and then we're going to multiply by 3. So this final answer for this one here is just going to be negative 2 sine of 2x minus 3 cosine of 3x. Straightforward, very simple. Again, when you're adding or subtracting trig functions, you really just have to do them separately, and then whatever the operation is, you keep it. Okay, so we're kind of getting to the same old stuff here, but I'm okay with that. So this one here is going to be secant of x quantity squared. You'll be surprised, ladies and gentlemen, how many people think this derivative is tangent, because you know the derivative of tangent is secant squared. But you do it just like this. You do it just like this. So you're going to go ahead and find this derivative pretty well and say that h prime of x is equal to, move the 2 down, leave everything inside the parentheses alone, to the 1 less power, so 1, and then we're going to find the derivative of secant. Well, the derivative of secant is secant x, don't forget the x, tangent x. And so this one right here, when you simplify it, it's going to be equal to 2 secant squared x, tangent x. This is a very common one that I see happen a lot in the exam, right? It's pretty nice, pretty straightforward. But again, chain rule, chain rule, chain rule, chain rule, chain rule. So the last 2 examples we're going to do, the last 2, number 20 and number 21. So for this one, again, ladies and gentlemen, I know I'm doing the same stuff over and over again. The more we do it, the better we come at it. So I'm rewriting it again, cosine of x to the 4th, raised to the 4th power. So h prime of x is going to be equal to, we're going to move this down, and for like the 75th time I've said this probably, we're going to leave everything inside of the parentheses alone. Leave it alone to the 1 less power. And then again, ladies and gentlemen, our eye goes towards this. We're going to find the derivative of what's now inside the bracket. So we're going to take the derivative of cosine, which is negative sine. And again, now for the 76th time, we're going to leave our what's inside our parentheses alone. And then finally, we're going to look at this, and we're going to take the derivative of what's inside of here, which is going to be 4x cubed. We call it a day. We call it a day. And yes, we can start putting things together, but that's totally fine. Then our final example for this video is going to be the sine of something. Now, guys, I will tell you that if I ask you to take the function h of x and it's equal to the sine of happy face, I don't care what theta is. I don't care what it is. Your derivative is going to be equal to the derivative of sine, so it would be the cosine of happy face. And then we're going to now focus on this. It's going to be the derivative of happy face. Good old happy face. So this is it. So it doesn't matter if there's no trig function there. Don't worry about it. And notice that there's no sine x here. Now, guys, that's a whole different question. If I told you sine x versus cosine x, it's the sine of a theta, right? So do not use the product rule here. So it's the sine of cosine of x. So we're going to find the derivative of sine, which is going to be cosine, and we're going to leave everything. There's our 77th time, right? I'm going to stop doing that. But we're going to leave everything inside of our parentheses alone. And just like before, now we're going to focus on the derivative of our parentheses. So the derivative of cosine of x is going to be negative sine of x. And so that's going to be the answer to our problem. It's going to be negative sine x times cosine of x. It looks weird, but it is fine. There we go. So that is a lot of examples, way too many examples. But you guys see I did the same thing for every single problem, right? Did the same thing for every single problem. And by the way, just because I'm going to do it, what happens if it were, what if I give you guys the function sine x times cosine x? What's the difference between that? Well, you have to use the product rule, right? You need to use the product rule here. You're going to have the first times the derivative of the second plus the second times the derivative of the first. And so you're going to get cosine squared x minus sine squared x. And this is one of our lovely identities as going to be cosine of 2x. So that's actually kind of nice that the derivative of sine of x cosine of x is equal to cosine of 2x. All right, which is a nice little identity for us. All right, guys, that's it for this video. The last video I'm going to do is going to be on just extra practice problems with trig functions and everything alike. So hopefully this is helpful. It hopefully was, because I did the same thing over and over and over and over and over again, right? All right, I'll see you guys in the next video.